what's called the conservative margin of error. This comes from chapter 5, the first one in chapter 5, which I can't remember the name of it. But in chapter 5, the first one, right at the end, there's a couple of questions that talk about this, right? So that's where it comes. The rest of chapter 5 we've covered. Wasn't it listening to me talk a lot in terms and different kinds of bias and different kinds of samples? Almost all of those questions, aren't they? Here's a story, pick one of the 4 that describes what's going on. So as far as your homework goes, it's just a matter of picking the right question. You know, the right answer to, I should say, the question. So we are going to look at 3 things. I've got them here. Conservative margin of error, which is a percentage, obviously. And this is the formula for getting it. We'll talk about what that is. Oh, I should have waited just a few moments more there. Somebody just turned up. Then, oh, maybe I should have waited even more because there's 2 more people turning up. Do you think they're trying to avoid my jokes? Okay. We're going into the details, but here is how you find the conservative margin of error. It's this formula. You then have to move on to how do you find what is called a 95% confidence interval, and this is the formula. And then you get a question that says how big does a sample need to be? And I haven't written the formula for that. So the size of the sample n is 1 over the conservative margin of error squared. But when you use this 3rd formula, the conservative margin of error is a decimal. In other words, you use the decimal version of it. Okay, now I've got the kind of the heading of it. Let's tell you how this thing works. Let's suppose, note to myself, send out an email. Let's suppose that we asked 1,200 adults, right? A nice random sample of 1,200 adults. And we went and asked them, have you ever been to Scotland? And the reason we're asking this question is that we like to find out, or try and estimate at least, what percentage of all adult Americans have been to Scotland, right? That's typically why you do samples, right? You ask a small representative group, and then you make the inference that if you do a good job at that, whatever answer you get, that's roughly going to be the same percentage of Americans who would be the same thing. So there's a guy called the conservative margin of error, and that would be question A. It would say something like, find the conservative margin of error, right? It would just say it right out. And it is 1 over the square root of n times 100, and your answer is a percentage. So you go to your calculator, and you do, where is it? 1 divided by the square root of 1,200. Multiply that by 100, and the answer I get is 2. If I round it off to say 1 decimal place, the answer is 2.9%. If you ever listen to the television, especially when it gets near to election time, but even before then, aren't there all lots of polls going on if you watch Fox News and MSNBC and all the other ones? And they say, like, President Biden's favorability rating is this percentage. And then they say the margin of error is 2% or 2.9%. You ever heard the margin of error phrase? Listen to it next time. And they don't always tell you that, but they should. They should tell you this. Now, what this number is indication of is how accurate your estimate is going to be. See, if I went and said to you, I conducted a survey and 20% of Scottish people in my sample said they'd been to Scotland, you'd say, okay, 20%, 1 in 5 Americans have been to Scotland. But I really don't know whether that's a very accurate estimate or a horrible estimate. I mean, I could have asked 10 people, couldn't I? Which case, you know, how reliable is that? I could have asked 20,000 people. So the margin of error is an indication of roughly how accurate it is. You want this number, or at least you hope it to be, very small. Because if it's very small, it means that your answer is good, right? So back to this story of asking the adults in my sample. Let's say that the percentage from my sample who said they'd been to Scotland, so the percentage who said yes, to make it straightforward, was 23%. That's fine. Question B would ask us to find what is called a 95% confidence interval. We tend to call it 95% C dot I for short. And it's the percentage who said yes. So you ask some people a question and whatever it was, 40% said, I'm going to vote for that guy. 22% says I'm in favour of this. In this case, 23% said I've been to Scotland, right? That's the number that goes here. And then it's plus or minus the conservative margin of error. So our 95% confidence interval is 23%, give or take 2.9%. So if you're listening to the news, they might say, oh, there was a new poll, a new survey conducted, and 23% of Americans have been to Scotland with a margin of error of plus or minus 2.9%. Hi, Brianna, is that little one yours? Right.
Yeah, he's stealing my big giant unicorn stuffed animal in the corner.
So this 23 plus or minus 2.9%, 23 take away 2.9 is 20.1%. And if you add it, you get 25.9%. Do you get a better feel now for how accurate my prediction is based on this sample? We would say that we are 95% sure the percentage of all Americans who've been to Scotland is somewhere roughly be, what, 20 to 26%, if you look at this. Now, it's a funny term, 95% confidence interval. You'd think, why don't they just call it a confidence interval? Or for that matter, why don't you just call it an interval? It's not just superficial. That number is actually telling us something. We are only 95% sure that this interval contains the real answer, right? The real percentage of Americans who've been to Scotland. If you look at that in another way, doesn't that mean there's a 5% chance that we were just wrong? This interval doesn't have the right answer. The real answer is miles away. And in statistics, that is what happens. We aren't ever, and if anybody says they are, they're lying to you or they don't understand statistics. We never say we're 100% sure of anything. I mean, in real life, couldn't I do another sample? In fact, if I did another sample of 1,200, would you expect every single time I get 23%? If I asked 2,300 or 1,200 different people, would you agree it would change a little bit every time? You'd expect that, just normal variation. So you can't be sure. Couldn't I just be really unlucky and got a lot of people who've been to Scotland? Might my sample had maybe more than is typical. And in that case, couldn't this interval be wrong because of that? So the 95% confidence interval means that whatever interval you've collected, you're only 95% sure that the real answer is somewhere in that range. Right? Not a guarantee, but 95% is pretty good. You don't know this answer, but you might be able to guess. Do you know there's 3 typical confidence intervals? This is the only one you're going to deal with. Later on, you'll see the other 2. What percentages do you think they might be? So this is a 95% confidence interval. What kind of numbers do you think the other 2 confidence intervals might be?
80%.
You might have said it, Eric. I didn't catch it, that's all. What did you say?
80%.
Oh, a little bit higher, but nice and round.
85.
No, that's not round.
95.
90%. So 90% confidence interval, 95%, and the last one is 99%. If you created a 99% confidence interval, wouldn't you feel really good that almost all the time you've got it, right? You know what the right answer is, give or take. You know it's in this interval somewhere, right? But there is no such thing as a 100% confidence interval, right? So don't believe anybody who says that they have done statistics and that is true, because it never is. Now, the third question is, how big does a sample need to be? This particular sample generated 2.9% margin of error, right? Let's suppose I want to do a survey and I want this margin of error to be, I don't know, 0.5%, right? So when I'm finished, whatever it is, plus or minus 0.5%, would you agree that's going to be a really tight interval? I should be really comfortable about my answer being accurate, right? But how many people do you need to ask to get that confidence interval? You see, it's kind of not so obvious. Well, the good news is there's a formula for it. The number of people that you need to ask is 1 over the conservative margin of error squared. But make sure that the conservative margin of error is a decimal. That guy is a percentage. The conservative margin of error that we are going to use is what that guy looks like as he is a decimal. How do you get 0.5% and convert it into its decimal or proportion version?
Move the decimal to the left 2 places.
Correct, or divide by 100 is also correct. Now, this is what calculators are for. 1 divided by 0.005 squared, and we are looking at, good grief, 40,000 people. And it doesn't matter what the question is. You could be asking them, have they been to Scotland? Are you going to vote for a Republican? Are you going to vote for a Democrat governor? Are you going to vote at all, right? Do you like beer? Right? It don't matter what the question is. If you want to get a margin of error, right? If you want to do one of these confidence intervals and you want a margin of error that's within 0.5%, you will need to ask at least 40,000 people. Can you see why that is very rarely done? Can you imagine how much money it costs to do a sample, a good, sample with all the things that we talked about in the last few days being taken care of, right? A nice, simple, random sample. It would, yeah, I could see it costing you $1 million. Not far off it. So Bill Gates is the only guy who's going to pay that money, right? But at least we now have a way of finding it out, right? Any margin of error that you want. Somebody give me another margin of error. A bigger one than that, just so we can do this calculation again. Pick any number bigger than, 0.5%.
1.5.
1.5%. Now, what you can do if you want to be sneaky is the next time you're watching the TV or listen to a radio show and they tell you one of these 42% are going to do this and the margin of error is 1.5%, right? For example, you can do this calculation and you can figure out how many people they asked. How many people do you think they asked to get this margin of error? Hundreds or thousands?
Thousands.
I think it would probably be thousands. Now, as a decimal, are we okay with that guy being 0.015? Are we comfortable where that came from? So the number of people that would have to be in a sample with this kind of margin of error is 1 over 0.015 squared. And my gut feeling was thousands, but I've been proved wrong before. But not this time. And now, I'm listening to the TV, and 20%, not 20%, that's too big. They tell me something, and they tell me that the margin of error is plus or minus 6%. Now, that's not totally unreasonable. I've seen margins of errors that are, well, at least 5%, at least. I've definitely heard of those. How many people do you think you need to get a margin of error of 6%? Hundreds or thousands?
Hundreds.
Let's sign up. Well, I guess round it off, 278 people. If you were only asking 278 Americans anything, should you even really pay much attention to whatever the answer is? Because I wouldn't. Can you get all sorts of weird answers if you just, by bad luck, right? So be really careful when you hear information about surveys, they tend to call them polls, on TV or radio, especially ones that are concerned with politics or something that's important, right? Like that. Pay careful attention to what the margin of error is. Because if it's anywhere close to 6, 5%, something like that, I tend to pay no attention to them, because it almost always means the sample was tiny. And I think, simple sample, small samples, anything. If you did a small sample, couldn't you get a large percentage of people who think my jokes are funny? I mean, it could harm, right? So pay attention to the details. Isn't the devil in the details? A lot of people just say, oh, 47% think this. But if it's 47% and the margin of error is 8%, do you know they probably only asked 100 people, right? Not a good sample. I don't pay attention to it. Now, if the margin of error is 1%, yeah, well, they must have asked at least thousands. Now I'm paying attention, right? Provided they ask the question right and all the other stuff that comes after that. Are we comfortable about this margin of error, conservative margin of error, give it its proper title, confidence intervals, and how big samples should be? Feel good about that? You don't get much. I think you get 2 questions and that's it. Oh, little thing someone brought up in my other class. One of those 2 questions that you get asks for the conservative margin of error as a proportion. Which one of these 2 numbers then do you write down if they say as a proportion? Because the other one says as a percentage.
The decimal.
The decimal one. When you see the word proportion, I want you to remember that it just means decimal or fraction, right? A half counts as a proportion as well, right? Decimal or fraction. And it's easier when they say percent, isn't it? Because it's obvious a percent, right? If there aren't any questions about that, let's talk about the test.